All right, everyone. Yeah, so we're going to start now. I just want to make one announcement. Well, first of all, this is going to be recorded. This is going to be recorded and uploaded to Canvas. So just to know that. The reason I'm doing this, of course, is because doggies, or not doggies, free teeds and school is, they're both closed today. So I have to be home with the kid. So there might be interruptions. I hope not, but we'll see. The one thing I want to say about recitations, I thought that, I mean, it seemed like they went fairly well, but the thing is that they were a bit crowded, and I think that there's different styles, different TAs have different styles. Anyways, there's been an update now, so I'm actually going to be holding one of the recitation sessions as well. So there are going to be 3 that you can choose from. So, you know, you can pick which one you want to go to. All right. Yeah, so that's those announcements. I just post any questions to chat, and then I can answer those. But I think now, without further ado, let's just we have kind of a lot of material to cover today, and I just kind of want to do it. It's yeah. Anyways, it's going to be, we're going to basically do all things SQL today. So with one small deviation, we're going to show a little bit of the old relational algebra or extended relational algebra. Okay, so we already covered a lot of this, kind of what SQL is. So this is what we covered last time. But the Northwind scheme, of course, is what you're going to be doing your SQL over in the exercise, or the lab rather. Yeah, so there's that. But the thing that we want to just kind of, I just want to start out with this kind of, let's just kind of talk a little bit about what's the difference between these two, because I think this, I mean, if you can understand this, I think you're a long ways, you're going a long way with your understanding of SQL. So what is the difference between these two? They're both selecting the attribute A from R, and they are basically doing a join between R and S on the value equaling B. Okay. However, this one does this first one here is just kind of, it's basically doing a Cartesian product and then doing the kind of theta join. So if there are if an A here, as it scans through the R's here, if one of the R's, or rather a tuple of R, winds up having there winds up being several B's that it matches on, then what will actually happen here is you'll actually replicate or duplicate the R. So I mean, the point here is that these are 2 different answers here. So if we look here, we look at an example right here. This is kind of good to have an example. So we have the relation R with these 2 tuples. And in the case right here, what you're going to do is you're going to do the Cartesian product between these 2. And we know that what a Cartesian product is going to be, it's going to wind up being 4 tuples in this case, 2 times 2. Now, 2 of those 4 tuples are going to match. They're going to have 1, 2, 2, 5 in the join, and 1, 2, 2, 6. So they're going to be 2 tuples. And in that case, what A will then wind up being is it will be duplicated. So there'll be A will be equal 1, A will equal 1, right? So 2 tuples will be in this right here. Sorry, it will be in this right here. 2 tuples will make it back. However, in this one here, only 1 tuple will make it back. So if you see right here, what you'll wind up doing is you loop over the R's, And then what'll happen is it'll just basically say, well, is there a B? Is there, or in S, is there something that matches this particular tuple on B? And in this case, yes, there is. Well, there's two of them, but one is good enough for this condition to be met. So in this case here, what it's doing is it's going to be looping over the tuples in the relation R. So in this case, only one A equals 1 comes back. All right. So I hope that that's clear to people, because that's kind of, I mean, to be able to see that is going to be that I mean, it's important to kind of understand kind of the semantics of how these things work and how how it goes through and decides what tuple to take. Okay. So that was that. I just wanted to kind of go over that because I hadn't done that example, but I hope that made sense to people. Again, any questions, put them in the chat. It's kind of one of the things that's kind of nice about doing lectures in person is that I could at this point now kind of maybe sense whether or not people had questions, but just by body language. But okay, so let's go on here. I think in this case here, we've already covered a lot of this material, but let's just make sure we get it all done for the sake of completeness here. So null values, outer joins, insert, update, and delete. Now, I believe we've covered this issue of null values quite a bit. And it's just the only thing that's in the slides here is just to understand that this is kind of how that three-value logic works, right? So how the conditions get evaluated. And remember, only conditions that are true, not false and unknown, those are the only ones that actually trigger a print on the select. Okay, so those are the only things that actually decide that this particular tuple is going to wind up being part of the answer, and it's going to have the select clause evaluated over it. And this is the example we showed before with this kind of issue of like, is it always the case that select star from this relation sells here, where we have a bar, a beer, and a price. In this case here, this does not wind up becoming an answer here because it's unknown for this and it's unknown for this, and unknown or unknown is unknown. All right. Okay. Now outer join, we also covered that as well. Now the only thing we didn't cover, we covered outer join in the extended relational algebra, but the outer join syntax in SQL is you wind up actually having on the from line, on the from clause, you can say R outer joins S. Okay. And then that winds up being a natural join, but that only works for certain dialects of SQL. All right. So now this is something that we haven't talked about, and it's kind of it's just kind of a clear part of the data manipulation language. But what we have here is we have kind of the notion of database modification. So far we've just been doing read queries over the database. Now what we can look at here is the idea of doing actually you have to populate the database in the first place. So we have the idea of inserting and then also deleting, because you maybe want to take it away, and updating tuples in the database. So the way inserts work, it's really, this is all very straightforward, but maybe I'll just kind of make some kind of comments just kind of as we go along here. But basically, its syntax, it's very kind of an old syntax, so it's not very, it's not particularly appealing, I suppose. I mean, it looks very, very old, but it's kind of what we're stuck with now. But what basically you do is you say insert into likes. So likes is a table here. And then basically what will happen here is it's going to line up whatever in the declarational order of the attributes is. It'll put the values in for Sally and Bud. Now, as it turns out, this is actually bad practice. What you want to do is actually in the insert, you want to name the attributes because it makes it much more, makes it much less error prone. So in this case, yeah, so specifying the attributes in the insert. So basically what you want is you want to have something like this. You want to say insert into, and then you want to have the attributes. Okay, so that's just kind of a good practice. You don't have to necessarily. Now there's the notion of of having default values. So in some cases you won't even specify a value for an attribute. And in that case, sometimes it'll actually it'll take what the default was. So in this case here, we have a default value of like this is in Sesame Street. Okay. Now, usually what default values are, there's stuff like now, like so when you do an insert and you want to have like, so okay, if they don't specify a time for the insert, just consider it like the insert is at this particular now point. So a lot of times its default wind up being functions that will return stuff. So this case doesn't really make any sense to make this particular address the default, but that's what it's doing here. So again, this is in the declaration of the actual table, which we covered a little bit. This is the DDL, data definition language, whereas the inserts, updates, deletes, and selects are part of the DML, the data manipulation language. Okay, so yeah, in this case here, if you just do this insert here of just like the name Sally, then you get a phone of null because the well, phone is okay. It doesn't say here, it doesn't say anything about the phone. So, and they're not specifying phone in the insert here. So it'll wind up going to the null value. All right. And then the address, of course, is Sesame Street and the name is Sally. Now you can actually go back here and say something like not null. Okay. You can say not null. In other words, we will not accept that attribute to be null. And in that case, this will wind up giving you an error if you do this insert. All right. Now this is really useful. This is quite often what you'll see. This is a very common usage pattern. One second, I just I heard trouble coming. That is my kid. The idea here is that what you wind up doing is you wind up having a subquery, and then you can insert into a table. You can basically suck off of one table or set of tables with any arbitrary query, and whatever the answer that comes back to that is, you can shove that into a new table or into another table that's been defined. And what happens in like quote the real world, I suppose, is you wind up getting like these really long cascades of these things so the information kind of ripples through a whole set of table definition. So that's a very, very common usage in the world. So I guess in this case here, you're basically inserting into I guess buddies here, pairs of drinkers that drink together. You're inserting into that table the result of this query here. Okay. So frequents, what bars they frequent or something, to that extent. Okay, so that again, this issue of having a subquery in here, we're going to contrast. I think we're going to get to views. We're going to talk about views today. So there's kind of a little bit of a different way of doing it, but this is there's kind of a tension here between two different ways of doing something that's similar. But again, this is this idea that you actually you might have a cascade of kind of data that kind of pushes through a system, and at the end you have these very, very high level tables that wind up having very aggregate or kind of summary information in them. It's a very common usage of this select into, or insert into the subquery. Using subquery. Okay. Yeah. So now there's deletion, of course, because we want to go the other direction. We want to take things away. So you delete from a relation where a condition is met. And so in this case here, we want to say, well, we want to say that Sally does not like the beer Bud. Okay, and that would be basically this. You delete where from likes where the drinker is Sally and the beer is Bud. Okay, so that's actually making the changes to the database. Now this right here, delete from likes. So this right here, this will wind up deleting everything from a table. So this will basically empty the table. All right, so there's no where clause. So you got to be a little careful with these things, but yeah, but again, I mean, I can talk a little bit more when we come to transactions about how you kind of deal with deletions and over like that. I mean, you always should have a backup of your database. If you start doing deletions, you got to make sure you got to be a little careful here. Not equal. What is the? Yeah, that's right. Yeah, so it looks like there was like kind of an answer there, which is correct answer in the chat about what the way you specify not equal. You can do it as a not and then an equal. You can have a not symbol, or you can have depends on the dialect of SQL. But I think it's pretty much universal that less than greater than basically will be not equal to. All right. So then which is what happened in this case here. All right, delete. Oh, okay, here we go. So we're going to delete some tuples. Okay, delete from. So this is kind of interesting. So we have this idea of, okay, with the beers, they have a name and a manufacturer. And then what we're going to do here is kind of a strange deletion. We're going to delete from beers all the beers for which there is another beer by the same manufacturer. So all beers that. So that idea there is that, like, yeah, I mean, it's kind of a little manufactured example here. But what we want to say here is we say delete from beers where there exists another beer that has a different name but has the same manufacturer. So any beer that is any beer that has another sister or brother beer that's made by the same manufacturer should be deleted. Okay, so in this case here, so suppose that Anheuser-Busch makes only Bud and Bud Light. Suppose we want to come to a couple of beef for Bud first. So basically, there's kind of an ambiguity here. You kind of think about it, like, what does this really mean? Because if I go and I basically do this query and I check and I come first to Bud and I say, oh, there's a Bud Light. So then I decide I'm going to delete Bud, right? Because it has a sister beer under the same manufacturer. Then the issue is that, well, what is the real meaning of that? Because then what happens when I come to Bud Light next? Now, Bud Light, you would think that since I'd already deleted Bud, then Bud Light would not get deleted, right? You would think. So, but that's not actually how it works in SQL. So the reason why, so you have to kind of think about, first of all, there's kind of a, well, first of all, I'll tell you specifically how it does it, and then I'll make a meta point about why this is the way that SQL wants to work. So the way that it actually works is that what you do is you go through, so on this right here, you're going to, the actual operational semantics. So there's like the semantics, like, which is kind of a meaning thing. And then there's operational semantics, which basically means how do we actually do this in SQL? Now, operationally, what you do in SQL is you're going to go through the full table of beers, and you're going to put a marker on each one that this is true for. Okay. And then you're going to go through and do a delete. You're going to delete everything that has a marker. Okay. So mark all the tuples where the where clause is satisfied, the where condition is satisfied, and then delete the marked tuples. That's how it works. So in that case, they both are going to get deleted, right? They're both of those beers are going to get deleted, because in that first stage where we're going through and we're just marking tuples, both are going to mark true for the where condition. All right. And then when the delete comes along, it's going to take them both away. Now, why? Now the meta statement. Now, why would this happen? Why would you want to do it this way? Why? Well, one of the reasons is because the semantics of SQL statements should never be like finicky and ambiguous, or they shouldn't be something. They should basically always be. They should always yield the same results under whatever ordering of the tuples there are in the base relations, and whatever, when we, like, you don't even know how SQL is going to decide how it's going to kind of scan through the tuples in the underlying table. But what we want to basically stick with is more like of a set semantics on those tuples. And so what we want to do is we want to have it so that basically we don't have any kind of really strange artifacts that kind of affect the results of queries based on the kind of internal physical ordering they are in the database. And had we done it so that we kind of do both the where clause and then, we're updating the database as we're doing the, if we had the alternative semantics where we just take the first one, then it becomes order sensitive. And practice says you don't want to do it that way. You want to keep things much more set and simple based. So that's the reason why we adopt this kind of semantics. So it's important to kind of know that. It'll, with practice, you'll kind of get the hang of it. All right, now we have updates. So what updates are, they're actually, okay, they're a way to go through and to change the values in the records or in the tuples of the database. So we have an example here. So basically, set the phone number to, this value here, where the name equals Fred. Now, if there's a lot of Freds in that database, right? If there's a lot of Freds, it's going to be applied to every single one of them. All right. So you got to be a little careful with that. Like, for instance, if you didn't have a where clause, this would then set everybody's number to that number. All right. So here's an example right here. Like, set the price to $4 if the price. This is actually this time I'm sure would be a favorite for many. That is to set the prices back down to $4 a drink. So if the price is over 4, then set it down to 4. If it's $3.50, then it'll stay at $3.50. Okay, so that's kind of that's what this query would do. Okay, yeah. So there's more to say about it. I mean, I think that one of the things you have to remember, of course, is that we'll get to it later, but of course you have like a host language like Python or C or C++ or something, and it actually is preparing these commands and then shipping them off to the database. right? So that's actually how it's mostly done in the quote real world, I suppose. That is that you have kind of application programs that are actually doing these these inserts at least, and these, maybe the updates and deletes as well. But the idea is then is that people aren't like people aren't actually physically typing these things. I mean, that would take forever, right? This kind of gives you the access to kind of a database model. I think some people call it the IDM model, the insert delete modification model, or modification, but it's the insert delete and update model. But it's sufficient to kind of build these CRUD applications. Okay, so I mean, this should be again fairly straightforward, but interrupt me if you have any questions. All right, so that was that. Now let's move on. So let's see here. What are we going to go and do next? We're going to do. We're going to return back to this issue of aggregation. So this grouping. Now remember, we did the grouping stuff. We did that for extended relational algebra, but now let's go in and let's do it for SQL, because there's a correspondence here. So aggregation. So okay, so we have the aggregate functions, and again, it's like the sum, average, count, min, and max. And then we also have this special one where it's a count star, which basically just counts the number of tuples, coming back. Okay. This count here, as opposed to this count here is going to go over something more specific. This is going to go over basically what's in a select clause. All right, so we'll see an example of that. So here we are. This is a real simple example of aggregation. This right here, there is no group by here because there is no group. I mean, it's just everything, right? There is one group maybe, and that's just everything because it's going over all of cells here. So basically, it's saying, well, we're going to apply, of course, the filter here, or the selection. Well, I'm sorry, a selection in a relational algebra sense, but in the SQL sense, a filter or a condition, a where condition. So all the beers that are bud. So these are, in this case here, this cells has like a bar that's selling the beer. So for all the bars that sell bud, what is the average price of bud? Okay, that's what this will report. Okay. So now, if you want to say distinct, so this is okay. So this would be something. Okay, let's think about this. Why we would want to do it this way here. So there's in this case here, what we're going to basically say is we want to say what are all, like, let's say that we have 100 bars, and half the bars are selling bud for $3, and the other half is selling for $3.50. So how many distinct prices are there? There's only two prices, right? So what this will return is 2, because how many different prices are there for the records of these bars selling bud? Okay, now had we not had the distinct here, then what it would return, it would be a big difference, because what it would do then is we just basically look at all the prices, allowing duplicates. So it would basically give us back an answer of 100, which would make no sense, which is not what we're after. We're after how many distinct prices are there. So that's why you'll see a lot of times that distinct will be brought in to the under. I mean, this right here is kind of like, this is the aggregate function, the count, and this distinct price is kind of like a little selector, which basically will go in and fetch the price out, okay, from the cells. All right, so I hope that makes sense. So you might want to put that in there. Now, here's the key thing. That is how do you deal with nulls when you do aggregation? And then a null will never contribute to a sum, average, count, and can never be the minimum or maximum of a column. Okay, so they basically, and the numerical ones, they just kind of go away. But if there are no non-null values in a column, then the result is null. So let's say that we had like all these records of selling of bud, but we had every one of them, we didn't know the price. They were all null. And then we say, what is the average price? That would be a case in which it would return, it would return null as the answer. Now, if we had one of those where the price was $1.50, then the average price would be $1.50. So it's very kind of a quirky aspect of SQL, but it's just kind of how it goes. Now, if you have a condition and you want to do a count, and then it's empty, then you get 0. So it's just like, these are just like little quirks you have to learn about SQL. Let's see, is there a way to count the number of null values in a set? Yes. So that would be count star where the value is null. Where so if I said I want to know how many tuples do I have in cells where the price is null, that would be select count star from cells where price is null. Okay. Let's see. Is there a way to count the number? Okay. But is it good practice to filter away the nulls anyway before using count and average? Well, it shouldn't matter if is so. I think that there was a good point here that somebody mentioned, but it is a good practice to filter away the nulls. So that's essentially what this is doing. That's essentially what this is doing. It's essentially, I mean, semantically, that's kind of what it's achieving. It's filtering them away. They're not becoming part of the calculation. So yeah. So that's a good point though, because I think that the comment here was like that's a good intuition about how we should do things. Is there a way to do it? Yeah, it is the kind of default behavior. So that kind of gives some insight into kind of a why behind these kind of strange policies. But that's, I like that. Very good. All right. Uh-oh. Trouble coming. So far so good. Okay. Yeah. Okay, now we're going to get to the part where sometimes people can find this a bit confusing, the grouping. So, I mean, we did this for the extended relational algebra, but let's just kind of go over it here now for SQL. So select from, okay, and a group by. So the group by is going to always be a list of attributes, and it will basically partition the tuples. So when I say partition, I mean, I hope you guys know what a partition is of a set. A partition in the mathematical sense of a set. So maybe, hey, Alex, show your off though. Sorry, one second. Alex, show your off. Yeah. I don't want him to eat pesticides. And probably. Okay. All right. Right, where was I? Okay, yeah. So a partition in the kind of the mathematical sense is like when you partition a set, it's like you basically just well, you form a covering. How do I say this? A partition of a set is a set of sets where the total intersection is nothing, but the total union is the original set. That's a partition. Okay. That's one definition for a partition. So with the partition, when I say there's a partition of the tuples of the underlying table on the group by attributes, it means that basically it's going to take the set of tuples, and for each of the different combinations in the group by attributes, it's going to form a group, and that will be a partition of the underlying relation. Okay, and then of course, as we know, it's going to apply to each of those partitions. It's going to apply the aggregate function. All right. So here's an example. Then, of course, this would be all right. So in this case here, the partition is going to be however many different beers we have. So we have the selling relation where we have the beer and then we have the price. So in this case, what we're doing when we're grouping by beer, if there are 100 different beers, and assuming that none of them are null in the underlying cells table, then we'll have 100 different groups. Okay, so the partition will be of 100. The partition will be 100 different groups in the partition. Okay, and then for each of those, it will calculate the average price. Okay, so that's how grouping kind of works. But you have to kind of play with it to get the hang of it. So what is this doing here? What is this example doing here? Right. This example here is from the cells and the frequents. Okay, so we have two different tables. We have like what bar is selling a beer at what price, and then we have a drinker that frequents a bar. And I apologize for this drinking example. It actually comes from the Stanford. They developed this. I don't know. I mean, it should be better. I think it'd be better if it was like health food or something. We're talking about people eating health food rather than drinking beer. But anyways, so select the drinker and the average price. Where now what we're doing here is we're basically saying frequents and cells where the beer is bud and they frequent that bar. and group by the drinker. So basically, this is computing all the drinker bar price tuples from for Bud. So this right here, but if you notice right here, this is like an underlying table. So this is the table over which the partition will apply. And then you're grouping by the drinker, right? And then you're going to calculate the average price that they're paying for Bud. All right. So what's the average for, you know, for the places that you frequent? What's the average? Okay, for the drinker, for the places they frequent, what is the average price of Bud at the place they frequent? For all the places they frequent, what is the average price of Bud? That's kind of what's going on here with these. That's what this query is answering. All right. Restriction on select clause within aggregation. Okay, so if any aggregation is used, then each element of the select list must be either aggregated or in a group by list. Okay, so this is actually where you'll see this happen a lot. So you have to kind of try to understand, why is this a faulty query? So I mean, you know, I've seen, so how many times have I seen this kind of thing happen and people kind of scratch their head, why doesn't this work? So why doesn't this work? Well, because, all right, so let's just kind of like just do it kind of like a litmus test here. Okay, so if there's any aggregation that's used, then each element of the select list must either be an attribute in the group by list or aggregated. So this right here, when it says bar and the minimum price from cells, okay, this bar here is not in any kind of group by. So this really doesn't make any sense, because the minimum over price, but that doesn't the way to solve this would just simply be to group by bar. All right. So I hope that people see why this doesn't make any sense, why this is kind of like kind of pointless, or well, it's kind of a semantic error. It's a semantic error in the query. Whereas if you just put in a group by, then it makes sense, because then the bar is actually in a group by clause. Okay. All right. Now, finally, there's the having clause, which is something special and something that that in general I try my best to kind of avoid if I can. But strictly speaking, well, okay, it's kind of like outer join, in the sense that the having actually is not necessarily in terms of the expressivity of SQL, but having the having helps efficiency. Okay, so it's just like the outer join, whereas you could in fact write something and you wouldn't need to actually have you wouldn't need to add outer joins to the SQL language. You could still achieve everything by just doing kind of more elementary operations in the language, but you have the outer join because it makes things much more efficient in terms of actually processing the queries. The same is true of having. So that's the reason why we have having. So what is having? What having is basically what it will do is when you actually compute the group by. So when you actually compute the when you actually compute the groups and the aggregate function in them, then it can apply a condition immediately on top of those groups. So on top of the result coming back. So that's what having does. Let's just see an example here. So find the average price of those beers that are either served by at least 3 bars or manufactured by Pete's. Okay, so the average price of those beers that are either served in at least 3 bars. Okay, so in at least 3 bars means that, all right, when we look at that aggregate function, it has to be applying to a group that is over the number 3. Okay, so what that's basically saying is this: hey, this right here, give me the beers and the average price from cells, okay, and group by beer. That makes sense. So if we just look at this query right here, that will wind up giving us back the like Bud average price of $4.95, Prips Blow $3.95, or I don't know, whatever it might be. Okay, so if we want to say no, but we only want that. So if there's some real esoteric beer that's only served by 1 bar, we don't want that in the exam. We don't. That's too few. We need to have at least 3. So what this is basically saying, the having count here, is it's saying the count of bar here in the cells here. Okay, so we need to have at least 3 bars. So this is also an aggregate function that is going over these groups. So you're grouping by the beer, and that's going to wind up having, that's going to wind up having like one particular beer at this bar with this, and then it's going to actually compute the average price. But the issue is this count of bars. How many bars did it do that over? In this case, it has to be over 3. So notice you have to do this kind of thing. You have to do this on the result that comes back from the aggregation. Okay. Now, you can actually do this with subqueries, but you have to then project out more attributes. It winds up being a real pain, but you can do it. So again, it does not add anything to the expressivity, but it's a convenience to have. Okay, and then we have another condition here where this actually has to do. Oops, this condition here actually just goes on actual the beer, just a simple kind of set condition here on the beer. Okay, so that I hope is kind of clear. Okay, so anything goes into a subquery. Outside the subquery is grouping attribute. Okay, so this is kind of just telling you, it's kind of common sense about how you can actually use the having. But in general, I would kind of it depends. If you need it, you need it. But sometimes, I try to keep things simple and not have it. Okay. I guess, but it does come up. Okay, so let's see here. So now, what do we want to do now? Well, what we want to do now is we want to look at one last little piece here. And that is, recursion. Okay, so what I want to do here is I want to kind of just go over to here, and I hope that I'm assuming you guys can see this piece of paper here, because I want to do it first. I want to do this in relational algebra. Okay, so good, people can see this. Okay, so let's start out with this. Let's just say we have the following. We want to represent. Okay, so I guess the issue might be like we want to represent a graph. Okay, so how do we represent a graph? So in other words, here's the graph. I have. Okay, so here's the node A, here's the node B. Is this big enough? Can you guys see this? Is this, I know that okay. We have A, B, and then we have B. From B, you can reach C. Okay, and then we have D over here, which is just kind of isolated. So we're trying to represent a graph here. And then what we'll see with recursion, I'll just make this E. And then I'll point E back to A and try to make it a kind of cyclic. It doesn't matter. So how do we represent this in a relational database? It's pretty simple. E basically, this is the edge table, E table, and then we have I don't know, what do we say? Let's say I don't want to say from. I'll say I don't know. Anybody have a good name here? E, like this is the what do they call it? The incident and the let's say I'll just do it. I'll say from to. Okay, so E from to. So what does this look like in the actual relation here? What is from to? It would be basically something like this: A, B, B, C, and then B, E, and then it would then be EA. And then we also might want to have a vertices table, which would basically say, okay, node. And that would include A, B, C, D, and E. All right, sorry about that. But by that you could see that D is isolated because otherwise you don't have a D anywhere. All right, but I'm assuming that's clear. This is how you represent a graph in a database, right? Of course, the opposite question comes up: is that can you represent a database in a graph? And you can do it at a very surface level, but you can't do it at a very deep level. So this is actually more powerful in many senses. The relational databases are more powerful than graphs. Okay, now that is controversial. Some people will argue to the end of the earth, but I think I'm willing to have that argument with anybody. about relational algebra. Like logic is more powerful than graphs. Let's put it that way. Okay. I might need to look for some more paper at one point. Okay, anyways. So here's the question we want to deal with here. We want to do with reachability. Okay, so we have an issue of reachability. So that's another relation, R, which basically means can I reach B from E? And the answer is yes. Has the camera frozen? Yeah. Camera froze. Let's see what state the camera froze at. Yeah, this is actually kind of this is a bug that has persisted inside of Zoom even over the newer versions. It's kind of it's regrettable. Yeah. So one of the problems. Could you stop the screencast? Yeah. See. So okay, the screencast. Okay. See, here's the thing. If I stop the share, okay, I did that. Now the issue is this: is it still frozen? And I think it will be. Is the screen still frozen? Oh, where's now my chat? Is the screen still frozen? And it's frozen if yep, it's frozen, right? You guys can't see my hand wiggling here. No? Oh, it's just black now. I got it. Okay, here's what we're gonna do because this is kind of a known problem. Like if you're doing a screen share and you're also doing the camera, then Zoom wedges up, and that's what's happened. It's wedged up here. It's really kind of unfortunate. But my theory, of course, is that Zoom is that they're suffering. They have so much technical debt they can't solve their errors anymore. So I'm sure this has been reported to Zoom many times. That basically you stress it out if you do both screen share and you do the camera. It's really silly. But anyways, why don't we do this instead, just to kind of like, because there's one solution, and that is I restart the meeting. So why don't we at this point take our break, and then we'll come back and we'll just and then I'll resume at 10 minutes after. So let's come back at 11:10, and then I'll start out with just doing the camera and not doing a screen share, and then hopefully we'll be in better shape. So I'm afraid that I'm going to have to restart the meeting. But again, let's come back at 10. Let's come back at 11:10. So okay.